talk about some of the things we're doing at Unitary Fund to build the quantum open source technology ecosystem. So Unitary Fund is a nonprofit organization. We're helping create the quantum technology ecosystem that benefits the most people. And we do this in a few different ways. So one is our microgrant program. So there are $4,000 grants for projects in open quantum technology. We also have a couple of internally driven but fully open source projects, MITIC, which is a Python toolkit for quantum error mitigation, and Metric, which is a community-driven quantum computing benchmarking platform. It's on the web at metric.info, and I'll talk a little bit about each of these today. I just want to quickly introduce the team. Dr. Will Zhang, our president and founder, Dr. Nathan Shama, our CTO, and in addition to myself, we also have Nate Stamen, who's also a member of the technical staff, and Ben Kastanen, who's our chief of staff here at Q2B. So be sure to connect with us these next couple of days, and it's great meeting all of you. And I also just want to quickly acknowledge our alumni, in particular, Dr. Sarah Kaiser, who's now a developer advocate at Microsoft, but has been a key part of building our quantum community at Unitary Fund. So in addition to our core team, we have a thriving community. We have people we call quantum ambassadors. So these are community members who've contributed a lot and connected with the quantum tech community. I was one of those before I joined technical staff last year. And this year we're about to announce our 2022 ambassadors. So I'm really excited for that. In addition, we have our grant winner community and our advisory board. So those are 19 volunteer experts in quantum systems and software. They come from many of the major industry players, as well as government and academia. And they help us review the grant applications and mentor our grant winners. We also build up our community by hosting open source projects. Quantum open source projects. So Q-TIP, for example, it's a classical tool for simulating quantum circuits and quantum devices. It has over 1 million downloads. So some of these communities are already quite large and thriving, and others are just starting out. We also host a hackathon called Unitary Hack, and that is for quantum open source projects. And what happens is quantum open source projects will come to us, or we'll reach out to them, and they tell us what they would like our hackathon participants to work on during the hackathon. And then we gather all of those issues, assign bounties to them. And this past year we had over 30 participating projects and 66 bounties collected. This year was also the first year that we did the Quantum Open Source Software Survey. So those of you in the software world might be familiar with the Stack Overflow survey. It's somewhat similar to that. And it's to give a snapshot of everyone in the community who is somehow working with quantum software tools, open source tools. And we got over 1,000 responses, and this was just our first year. So we're looking forward to many more when we do it again next year. And finally, we host weekly community calls for quantum open source projects. So I already mentioned our internally driven ones, Metric and MITIC. We also have the QIR Alliance hosted on our Discord. You may remember them from Q2B last year, and some really exciting announcements from them. They're still going strong. We also host Q-TIP calls. OpenQAOA recently joined our Discord from Entropical Labs, and Covalent also from Agnostic. And anyone can join these community calls, no matter what your experience level is, or where exactly in the ecosystem you are. Please join us at discord.unitary.fund. A bit more about our microgrant program. So $4,000 for rapid projects in open quantum technology. We fund explorers around the world to work on quantum technology, and you can apply at unitary.fund/grants. And just to highlight some results from the grant program so far, which just started in 2018, we've already given out 68 microgrants with recipients in 23 countries. Our recipients have generated over 20 publications, over 30 open source libraries, thousands of commits. And although we do not fund startups, a couple of startups have spun out of former microgrant projects, as well as one nonprofit that was spun out of a microgrant project. And our approach, it's no strings attached, so no equity, no interest. It's explorers in quantum, so students, researchers, hobbyists, professionals who want to do a side project, who are excited about building up the ecosystem and want to fill a gap that they see in the ecosystem. So again, highly encourage everyone here to think about applying or let someone know who has a great idea in quantum technology. They want to make it open source. Please consider applying to the Unitary Fund Grant Program. And yeah, these are generally open source projects, but they're also community building projects. So it doesn't just have to be a Python library. It could be an educational project. It could be about serving a community within the quantum ecosystem that maybe could use some support. They're usually 3 to 6 months duration, and the application only takes a couple minutes. So we try to make it as light and as efficient as possible. A few microgrant projects I'd like to feature. One is QRAND, so that was a quantum random number generation framework. PK, people interested in quantum universal education. I think the name is pretty self-explanatory. And Toucan, a quantum circuit compiler for 2 local qubit Hamiltonian simulation problems. So this was actually a combination, this last one, of a library, an open source library, but also some additional research that went into improving the compiler performance and evaluating different methods. A little bit more about open source for those of you who might be new to it. So why contribute to open source? Well, you can make a difference. You can build something that's available for everyone to use. You can build up quantum technology in a way that's something that others can then learn from and build on. But you can also advance your career in quantum, in software, and much more. And of course, it's fun. You get to meet new people. You get to solve interesting problems. What can you contribute? Code, infrastructure, so things like actions and workflows on GitHub, documentation, user interface design, data. I'll get to that in a moment with our benchmarking platform metric. User feedback is also always welcome and appreciated in open source projects. And how to get started: find a project on GitHub, join a community on Discord. There are plenty of forums, events, community calls to help you connect with the community and find a project that you're really excited about. Speaking of metric, so this is our benchmarking platform for quantum computing. So it's like Papers with Code, but for quantum. So anyone in the community can go to metric.info and can upload data, can input data into the UI. It's a web app. And you can do that from an archive paper. You could do that if you have raw data. You could do that from a blog post. You just need to provide some minimal information with the link to the reference and what the benchmark actually is. So what was the task, what was the result, what was the platform used. And to give an illustration of what that looks like, here we have a chart that's generated automatically, and it's log quantum volume. So you can see from, it's like 2019 to 2022, a number of quantum volume benchmarks here. And text is kind of small, but it's actually showing the different platforms used. Now, of course, this plot is incomplete. So please help us fill in the missing data. please submit to metric. So, and it doesn't have to be quantum volume. There are a lot of other tasks that we have that you can submit benchmarks for. So now switching a bit to our other internally driven but open source project, MITIC, which is a toolkit to apply different error mitigation techniques. So this is not error correction, this is error mitigation. So doing some simulation or some post-processing to improve the results we get from the quantum computer. It's compatible with many front ends. Cirq, Qiskit, PyQuil, Bracket, PennyLane, OpenChasm, and it's back-end independent. So you can use a simulator, you can use hardware, you can access it a number of different ways, and you can just wrap your quantum program with MITIC. And the techniques that we currently support are zero noise extrapolation, probabilistic error cancellation, Clifford data regression, and digital dynamical decoupling. And we also recently added functions for readout error mitigation. We don't list it here because we haven't documented it yet, and it's very new. But we are still adding techniques to MITIC, so more to come. And MITIC is being used to improve results on hardware right now. So, for example, it's been used to reduce errors when running mirror circuit benchmarks. We get an error reduction factor of up to 3. Or our B circuits, we saw an error reduction factor up to 7. Can also increase effective quantum volume and enhance simulations of quantum field theory models. So here we actually compare, Emily Huffman's group used MITIC when simulating quantum field theory models and used a combination of readout mitigation and ZNE to get closer to the simulator value. And so this is a typical workflow in quantum software, just to give you kind of a sense of where MITIC is in all of this. So typically, user generates a quantum program, and we've listed a few popular front ends, and then executes that on back end and gets an expectation value, especially in the case of like running a variational algorithm. And MITIC is like a thin layer between the user and the backend. Here it looks kind of thick, but it's actually meant to be pretty light in terms of the implementation. So what it does is it takes the user's quantum program, generates programs from that intermediate circuits. So it could be noise scaling for ZNE, it could be sampling for probabilistic error cancellation, and then sends it to the back end, could be hardware, could be a simulator, executes those programs, the noisy results come back, and MITIC performs an inference step on those results. And then you get an error mitigated result, so you get a result that is more accurate than you would have otherwise when running your noisy quantum program. So I just want to leave you with a few final thoughts. So first of all, that open source communities continue to add value to the quantum tech ecosystem. And at Unitary Fund, we're doing that in a number of ways, through our microgrant program, through our open source projects, MITIC, Metric, and hosting many others. And your contributions can help them grow, whether you have an idea for a microgrant, or if you want to perhaps join our member program, or if you just want to be part of the community and join a community call. All of those things are welcome and appreciated, because wherever you are in your quantum journey, your contributions count. Thank you. No Q&A? We have 5 minutes Q&A. Okay. Any questions?
Thank you for a nice presentation. A quick question: do you award or some kind of recognize your contributors on the platform?
Sorry, I didn't quite catch that.
Do you recognize or give some kind of an awards for your contributors at the platform you mentioned?
Well, we have a couple of different things. I think what you're thinking of. Whoops. I think what you're thinking of is the hackathon. So awarding prizes. Yeah. So we have a hackathon every year where we invite open source projects to post their issues, and then participants, if they solve the issue successfully, if they're the first one, then they get a prize.